This will be the shortest one. I want you all to own it, sign it, make a graffiti comment. I don't care. If in fact phi is the elevation angle of a vector and theta as the azimuthal, and I want to point this out, go out to Wolfram and see how it is flipped there. So you kind of have to keep track of that. If theta is the azimuthal and phi is the elevation angle, then this matrix describes a three-force concurrent system internals, and this does a two-force concurrent system internals. What I want you to see is this stack here, and this stack here, and this stack here is no different than the unit vector description for that vector, or the unit vector description for this 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 vector. Of course, as we know, right, when we're doing these concurrent force problems, we want to show everything in tension. And we spent a lot of time, and we'll continue to spend a lot of time looking at the trig, because this is what you've been studying. But in effect, this here is just going to be a unit vector. So if you take the sum of this squared plus this squared plus this squared, square root, you'll get 1. Same thing here, same thing there. You will soon see how sometimes efficient it is in CAD, sometimes inefficient, but how important coordinate systems start to come into it. Because if all of a sudden, if you want to start rotating things, like you look in your survey book, if you have a, or in Wolfram, you're going to take one vector matrix by another vector matrix. So remember, you can own this. So I want you to be able to look at this and make sense of it, not your calculator, not anything else, that this basically is the unit vector for one vector, the unit vector for the other, and the unit vector for the third. Remember, when you write this down, it is probably easiest to first write the z, because that's the one that you're just stripping out the up version, and then write the x where you stripped out the over and then stripped out the x by doing the cosine of theta, and then for the y you stripped out the over and then you stripped out the y portion. The sum of these squared, each square rooted, equals 1. Own this, sign it, and start applying it by mixing, getting some of these angles and the like, or just the deltas from AutoCAD and dealing with unit vectors. Revit is going to be the same as we start to relate files together. You need to kind of get a hold of this coordinate system and the visualization. So that'll be the first thing you'll do in class today. If you cannot process this in the context of what we've been doing through the year, let me know at the beginning of class. Thanks for listening.